Welcome to the UNBC Forestry Club Podcast. This podcast is recorded at the Seaford radio station on campus from the traditional unceded territory of Clayton Tenay. You're probably listening from other places in BC or Canada or maybe around the world. We encourage you to recognize the traditional territory you get to learn, play, and live on. All right, welcome back, smart people. So this is another really special episode because Dr. Elkin is in the house. Boop, 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 boop. So we don't need fancy introduction for Che. I got permission to call you Che on the podcast.
Please do.
I typically ask what do you want to be called, and but for everybody that's taking forest ecology and management, eventually you will get to know Che. And this course is called the Forest Modeling. Highly recommend it. Really put everything together you have learned in school, and then it's kind of like a wrap-up course, I would say. Just put everything together, and then so for today there are a lot of things I want to talk with you, Che, but I want to hand the microphone to you for now. Please tell us about yourself and basically just where did you go for school, how did you become a prof at UNBC, and just how do you end up being my professor for forest modeling, if you don't mind.
No, that's a great question. And I'd love it if I could tell you a really nice, simple, linear story that I grew up and knew that I always wanted to be a forester and a forest ecologist. In actual fact, there was a much more twisting route to get here. So I'm from Saskatchewan originally, and the joke that I always make is that until I was in my 20s, I thought trees were never higher than a couple meters tall.
Oh, wow.
But yeah, growing up in southern Saskatchewan, did my undergraduate degree in general ecology at the University of Regina. That kind of started up a passion for trying to think about how ecological systems operate. Kind of the drivers, worked with some really great plant ecologists there, frankly. But when I was thinking about the next steps, I was more interested in animals and specifically in insects. So I actually started off my career, my kind of true research career, as an entomologist. Went out to U of T, the Mississauga campus there, to do some entomology work, asking kind of really behavioral questions about how damselflies, dragonflies actually do microhabitat selection. So quite a bit different than trees, but that kind of, again, whet my appetite for doing biology, doing ecology. And during that degree, I was working on individual organisms and kind of really interested in what their individual behavior was. But I knew that I wanted to start asking questions about what are the population consequences, what are the community level consequences, landscape level impacts that we may be looking at.
Right.
So after that degree, I said, well, I really like this. I'd like to do a PhD. So I started looking around for supervisors to do a PhD. And the person that took me on board was Mary Reid at University of Calgary. So another entomologist working on bark beetles. And this is where I start to dip my toes into the forestry world. So I did a degree that was, again, very behavioral orientated with Mary, looking at how mountain pine beetles find the trees that they choose to attack and whether or not they're making different decisions if you're at a really high population state versus a really low population state.
Right.
So again, kind of making this step from behavior of what individuals doing to kind of landscape level impacts. And you two are both way too young to remember mountain pine beetle and its real big glory. But early 2000s, that was something that we're obviously putting a lot of thought into and trying to think about, well, can we better predict how mountain pine beetle spreads are going to occur and how that spreads the landscape? So that pushed me more towards the landscape, community, population level stuff. It also gave me an introduction to ecological modeling, and I realized, wow, this is really fun. If we can talk about beetles, we can look at beetles, but then we actually think about, well, how do we actually model these things in a way that allows us to better manage the ecosystems that we're interested in?
Right.
So that moved me towards ecological modeling. After that, as we do in academia, I was looking for a postdoc position, and this is where I took a little bit of a tangent, went down to Australia for a couple of years, worked on what's called a mound spring system there, looking at this tiny little snail species, a couple of millimeters long, and asking questions about how these snail populations respond to water fluctuations. That was great. Again, kind of deeper down the rabbit hole of ecological modeling. But after that, got an opportunity to move to Central Europe, Switzerland, to work at one of their premier institutions, and basically that whole focus was on forest ecology and specifically trying to understand how climate change impacts mountain forest systems throughout Central Europe. So a lot of my research was actually in Switzerland, Zurich based, but we had a bunch of collaborators all throughout Europe, and that was really when I kind of got my real emphasis on forest ecology. From that, I eventually, after being away from Canada for about a decade, thought to come back to Canada and was looking around for positions. And luckily enough, there was this lovely position at UNBC that attracted me here in 2015. So I've been here about 10 years at this stage. So that's kind of, how I got here.
That's very impressive. You've been traveling around the world, hey, doing research?
That's something that people maybe don't think of as much when they think about a career in academia. It can give you a lot of opportunities to work with really good people and sometimes work in really interesting areas. We all choose different paths. That was the path that I kind of chose. And like I say, I didn't know in my undergraduate what I wanted to do. At that stage, it really
like
was.
Me right now.
Well, and that's kind of why I'm saying that, and that people should not freak out if they're in the middle of their undergrad, kind of come to the end of undergrad, and they don't really know where they want to go. That's fine. It'll likely work out. Do your best, think about what you're really passionate about, and explore that as much as possible, such as doing podcasts.
Yeah, it's just a little bit time consuming, and it is fun to get to have this opportunity and this platform to talk to people, though. And this is why we can sit down and have this talk and learn. We've been chatting since forever ago, and then I never know your history of your education, how you got that here. So, this is one thing special about podcasts is just we have time to really sit down and calm and have a conversation, basically. And today, I really want to learn more about this fascinating ASCC trial. Fun fact, I keep calling it ASC trial. So apparently it's ASC trial. I've been calling the wrong name and nobody ever corrected me, so I got away with it. So for those people that have no idea, so basically it's a trial that, how we can manage our forest to combat climate change. And climate change is one topic that I think the conservation side of things and development side of things found in harmony. Like if you go to every conference, you go to biodiversity conference, people talk about climate change. You go to the conference that are advocating for forestry, they talk about climate change. It's something that every conference that everybody talk about. And so this is, as far as I know, the first couple trial or scientific study that is kind of targeting how forestry can manage the forest to combat climate change or adapt to climate change. So I'm going to hand the microphone to you again. So what is this ASCC ASC trial? Yeah.
Well, maybe just to build on what you're saying there, and climate change is obviously extremely important. It kind of impacts almost everything that we talk about as ecologists, as foresters, as forest managers, because there's currently a big impact that's kind of observed through changes in fire disturbance frequencies and whatnot, but also projected to have really big impacts across the board going forward. So this is something that has been on researchers' minds for, I'd argue, 20, 30 years. But we are at the stage where we're really starting to look at more, what can we do? Can we use silviculture to actually mitigate some of the negative impacts that climate change may have, or at least allow us to transition into forest futures or futures for a forest that are going to maintain some of the kind of key ecological services that we derive from our forests, be that timber, be that carbon storage, be it biodiversity like you're talking about. Mm-hmm. So, the ASC trial, and I never actually realized you're mispronouncing it. I just heard ASC.
The whole time.
Maybe I just changed in my brain whenever you say it.
I did a whole video about it, so now I'm like, I don't really want to go back and watch it. Anyway, sorry, keep going.
But so the ASC network is actually a really big network that's throughout North America. I was looking at the ASC website today, and right now there are 14 sites spread throughout all of North America. The majority of them are in the United States. but there are 2 in Canada. So we have the nice distinction of being the most northern ASC site at John Prince here, and they're in the John Prince Research Forest. There's also a really nice installation at the Petawawa Research Forest out in Ontario. So we're the 2 Canadian sites. And then in the United States, there's sites that kind of go right across, down in Florida, up into the eastern seaboard in Colorado. And this really highlights one of the key strengths or one of the key objectives of the whole ASC network. And that is to look at forest management across a wide range of different forest types and forest climate, forest environments. And ask this very general, not general question, this very similar question of how we can actually use our silviculture or forest management to maintain the goods and services that we want from our forest ecosystems. So the actual history of establishing the John Prince ASC trial was back in 2019. I was contacted by a researcher from Northern Arizona University, Kristen Warning. She was thinking, well, I've had contact with other ASC sites in the United States, and I'd like to maybe see about establishing other ASC sites in Canada and Mexico. So she was on a year sabbatical basically at that stage, and she came up here, spent 6 months with us. Basically, we had some really good discussions about what this would mean to set up an ASC site, and then started the legwork of actually trying to find a location within central interior BC that would actually be conducive to setting up one of these large-scale installations. And I'm sure we'll talk about this more, but they are fairly large-scale. So the whole ASC framework requires that the different network sites use a similar framework for establishing the different treatments that they're looking at, and also requires the size of the treatments to be large. So in our case, or not in our case, in all the ASC trial sites, the aim is to have each individual replicate be 10 hectares. Mm-hmm. And it's at this stage that I always have to give the qualifier that in forestry we say, well, 10 hectares isn't that big.
No, not at all.
I agree. However, when you're doing a research trial, this is a little bit unique in that you often don't get the chance to do replicated research experiments on this type of scale. So that really is one of the kind of objectives of the whole ASC network, is not only to have a properly designed, properly replicated research environment, but to make sure that it's actually done on an operational scale such that we can have operational scale learnings about what it actually means to do the different treatments that are going to be devised, what that means for forest ecosystems in general. So I agree with you. It's not massively big.
I will say it feels big when you have to walk to every corner of every hexagon.
By the way, that's Jack, by the way. I totally forgot to introduce you. I mean,
I've been on the podcast before, and I'm on this one because I helped Che out a little bit with some data collection this fall, where we had to walk around to the different, pretty much the whole, every single area in the trial, I would say, like every corner of every hexagon. So
No, yeah, so you should give a little bit more background to why you know the ASC so well there, Jack. So to set you up, one of the things that we're monitoring is how the different treatments, and we can go back talk about what the treatments are, but let's just say there's 5 different treatments spread across the John Prince Research Forest. The whole ASC site itself is 200 hectares. And what Jack and I were doing was going out collecting some of these temperature, relative humidity, soil moisture probes throughout the whole site. So I'd argue that you actually know that site well, because yes, we had to go into each treatment, across each treatment. How was the weather condition that we were working with during that weekend?
It rained the whole time.
Oh, really?
Yeah.
That's a dry ecosystem. That's I'm sure we'll talk about it. That's the SBS DW3. That's the dry, warm 3. That's anyway, it's just a dry ecosystem. But before we get into the experimental design, so why did you pick John Prince and not Eliza or some other places?
Thanks for bringing us back. Okay, so yeah, Kristen and I had discussions with a range of different people. We talked with Mike Joel at Eliza Lake. There is a community forest up near Chetwynd, the Chetwynd Community Forest. We talked with them, and we talked with John Prince. And BC's big. Central interior is big,
and diverse.
However, finding a area of forest that is roughly homogeneous or sufficiently homogeneous that you can put on these treatments and have the same effect size and has a uncut area that's kind of close enough together, that frankly is a little bit challenging. So yeah, we talked to Mike Joel and Eliza Lake. They were open, but it was frankly going to be hard to find the type of forest in the size that we needed to actually do this. Same with Chetwynd. We had some good discussions with them, but it just turns out that at the end of the day, it was Sue Granger. So to give a little bit of a background here, Sue Granger, we've got the, well,
shout out to Sue.
Yeah.
Person.
Which would be nice to have her actually on here with us, because she very much has been driving the development of the ASC, as well as myself and Kristen Warning. So we had discussions with Sue about whether or not they'd be interested in doing this, and whether or not there'd actually be an area that would be good. And it turns out there was a really fabulous area in terms of a continuous forest, all basically the same conditions. Some variation, like it's not all just flat, homogeneous areas. There's variation in the different drier sites, Doug fir dominated versus subalpine spruce dominated. But they were both willing to allow us to set up this experiment. And I guess the other thing I'll mention there is that all of the ASC sites have to make a commitment that they're going to follow these trials through for at least 20 years. So it's not only a large spatial area that is being committed to when people say that, yeah, we'd like to set up an ASC site. It's also a long-term commitment. And it's not only having the forest kind of maintained over that period, but doing the monitoring that's necessary to understand what's going on in this area. So yeah, it's as these things often go. You have discussions with a bunch of people, you get some traction in one area, and you just start leading the discussion more and more there. And what I will say is that having John Prince on board has been absolutely fabulous. This is a very big financial commitment, frankly, from them as well. And they had the foresight to say that, yeah, this is actually really important, and that it is great to support this type of long-term research for a really important question of how our forests will be impacted by climate change and what we can actually do about it potentially.
Is there funding for this? Is John Prince funding themselves, or is there a grant that's kind of fueling this project?
Yes and yes. And this kind of reflects whenever we're doing this type of really large scale research, you often have to dip into multiple different funding pots. Quite frankly, the biggest one is John Prince themselves. So the John Prince Research Forest has a mandate to advance research within the area to better understand how we can manage forests.
Right.
So because of that, they have been willing to make both a fiscal commitment for setting up the trial, but also the loss of revenue that they potentially get if they were going to do kind of conventional clear-cut harvesting on the site. So massive investment from them. But we also have to find other funding sources to support this type of research, particularly given the kind of longer time frame that's looking at there. And this is a continual, I don't want to say battle or struggle, but it's something we just continually always have to do. And luckily enough, we've been really lucky to attract some great partners. NRCan has been supporting some of our work. We have great partners with the province of British Columbia, the Ministry of Forest. One of the key site leads, Jody Axelson, has been a big proponent of ours, as well as other grants and funds that kind of keep both the graduate students, the summer students, such as Jack, that he wasn't out there for his own health walking around in the rain.
Wait, was it paid position?
Yeah.
Oh, I didn't know that. I thought it was volunteer or paid.
No,
okay,
yeah,
well,
I
it
would
was
not
some long days. I don't know if I'd have done it purely as volunteer.
No, I wouldn't expect you to. You probably didn't get paid enough for the tough conditions.
It was a very valuable experience. So definitely.
I'm kind of jealous because I want to learn more. I have so many questions about this. Yeah. Should we move on to the experimental design and how this? What are the treatments and what are the controls?
That sounds great.
And also, if Jack, if you want to interrupt anytime for any questions, go ahead.
Yeah, of course. Yeah, I mean, Shay's definitely the expert on the trial. I just have the on the ground kind of experience of being there with him, so maybe I can like chip in with some kind of like general forestry perspective on it. But yeah,
bridge the gap. Yeah. Sorry. Go ahead, Jay.
So did you want me to just kind of go over the experimental design in a little bit more detail?
Yeah, like why, basically what are the treatments and what's the idea behind those treatments?
Yeah. Okay.
And what those treatments actually realize in the ground, like what is, those kind of stuff.
And maybe how it ties into like the overall larger ASC trial, like why how does the experimental design tie into the overall larger goals of the ASC trial internationally?
And that's really important because I can talk about the background and kind of the general theory here, but then how that theory is actually implemented on the ground, that is what you saw as we were walking through the sites. And again, it goes back to this operational kind of nature of the whole experiment. It's not only doing kind of good research, but it's doing research that can be easily translated into how we should actually could modify our silviculture systems going forward. So to kind of go to the kind of beginning here, again, we have to start with this idea that there's these 14 ASC sites throughout North America. And the reason that we call it a network is that each site went through a specific design framework in order to get these different silviculture treatments on the ground. So the heart of the Adaptive Silviculture for Climate Change framework is having 4 treatments, one being a control, which in many cases is going to be do nothing. So in the case here, we have forests where we're just not going to do any type of harvest. We're going to let it be, maintain forest ecosystem services as they currently are, and then think about, well, what this means for harvest potential 20 years from now, biodiversity, carbon storage. So that's the first treatment. The other 3 treatments are various different levels of silviculture intervention that are basically designed to maintain the forest services that we want in the future, potentially at different durations, but make sure that we're trying to move the forest towards those conditions that we want, future conditions. So this is actually really important. You have to define what you want before you can think about how you can actually manage it.
Yeah.
So I'll just throw out the other 3 treatments there. So the first one is resistance. And you can think about this as, can we actually modify our forest in a way that makes it more resistant to some of the pressures that are going to be imposed by climate change? Resilience is the third one. So this is, can we make our forest more resilient to some of the disturbances or some of the changes that we expect in the future? A nice one that we can obviously think about is drought. Yeah. So can we actually modify stand structure, stand composition, so that it will not minimize drought itself, but make it so that the system actually is able to recover from those drought events a little bit better. And the third one is transition. So this is thinking about how we can actually actively help our forest transition into a state that is going to be more adapted to future climate conditions in the future. So I'll just go through those 3 again.
Yeah.
4 kind of control, and then the 3 treatments: resistance, resilience, transition. And the way that I often like to describe these or talk to people about them is they're kind of along a gradient of the level of silviculture intensity. So the resistance there, we're going to give the system a push, but it's not going to be a massive push. We're going to modify it a little bit, but basically a lot of the structure, a lot of the composition we're trying to maintain. Resilience, we're going to push a little bit harder. We're going to shift structures around a little bit more, but it's still going to basically look kind of like what our forest ecosystems look like, with the understanding that we do expect it to change a little bit in the future, but we'll come back to the state where it's still delivering those services that we want. And then the transition, this is a really heavy push. We're actually doing some big interventions where we're thinking about pushing the system in a way that is going to be better adapted to those future climate conditions that we may expect to see in 2030, 2040, 2050, 2080 in the future. So just to kind of jump in there with an example, this would be looking at areas, do we want to do assisted species migration? Do we want to shift our planting? Do we want to put some species that right now may not be perfectly adapted to the SBS? But if we think about what the SBS is likely to become in 20 years from now, will they be better adapted then? So going back to the whole ASC network, each network is required to kind of put in these 4 different treatments. We wanted to put in a 5th. So in central BC right now, for the past 30 years, our business as usual management has been
clear cut.
So if we didn't put in a clear cut there, we're not really reflecting what we do as foresters currently, even though we may be changing in the future. So we want to actually put in 5. So we have, again, our control, resistance, resilience, transition, and then clear cut as well. And they basically go, again, from this gradient of low impact silviculture to really, really high impact silviculture.
The whole time preparing for this podcast, like, so these 5 treatments, I knew this already because I went for a field trip. But the thing I didn't learn when I was in field trip, which I wish I learned if I can do this again, is contrast and compare these 5 treatments, starting from the harvesting. So what is it? So this is the idea, the principles behind these treatments. So what is the site plan? Like, what is actually, how much volume do you take? How do you take them? Is it irregular, regular? It's like a polygon within polygon? Like, so probably let's start with control. Control, which is no treatments, don't touch it. So what is the forest structure that's not touched? What kind of forest do we have in jump prints right now?
Great question. And I'll put out the qualifier here that what I'm describing is this one area in John Prince where the ASC trial was set up, which does not really reflect the whole John Prince area, because as you mentioned, it is actually a dry forest type. There's a lot of really nice big Doug fir there, drier areas, south-facing slopes, kind of classic Doug fir territory. The area where the ASC trial was set up has a little bit of Doug fir, but it was actually an area that had previously had a diameter limit cut put onto it. So this is why it would be great to have Sue here. I forget the exact years that she said it was harvested, but let's just put it somewhere around the 1960s, 1970s, where they were doing harvesting at the time, and it was diameter limit cut harvesting. So going in, removing the bigger spruce, bigger Douglas fir, basically taking out the pumpkins, the really nice ones, and leaving what they didn't want.
Kind of a high grading in forestry slang.
Well, you're using the terminology there. Yeah, there's negative connotations to high grading, but since you used it, yeah, it's exactly high grading. They were
there's
taking away.
There's another fancy name, intermediate utilization.
Yeah, exactly.
The IU log.
And
basically saying the same thing.
I don't want to go off on a huge tangent, but I think high grading got a really bad rap because of maybe some of the coastal practices where they would take like maybe 1,000-year-old cedars and stuff. But some of the older blocks I've seen in the interior that were high graded in the 60s or 70s, like it seems like it actually did the forest some good. Almost like they recovered really well, and they almost have an old growth feel to them now. So I would like to cast some or defend high grading a little bit.
Yeah, I think it depends. But since you're high grading, you definitely drive the forest structure into a different state because you're taking out, because we're targeting big spruce and Doug fir, and then you're promoting subalpine fir basically, because you have spruce, Doug fir, and balsam subalpine fir kind of growing in there. You can take all those big spruce and Doug fir, and now you're giving lots of growing space for subalpine fir. So you have those forests, IU log, they have lots of balsam content in there. Is it good or bad? I think it depends on what our objectives are.
Well, I'm going to say both you gentlemen are actually correct in that, when we think about high grading historically, it has been removing all the good growers. And if we look at it just through the lens of timber, this often really isn't the best thing we want to do. You're not leaving the growth potential, the actual high quality trees on the landscape. So it historically has been seen as really, really negative. But to your point, Jack, we can go back to some of these sites where they were high graded, diameter limit cut in the 1960s, 1970s. These stands are some of the really nicest ones we have that are managed stands, having a lot of the characteristics that we often associate with old growth forest, really big diameter distributions. You're getting a gap structure that is often associated with old growth forests. You're getting a lot of that habitat complexity that actually may be good. So I fully agree that depends on how we look at them. Are we looking at them from biodiversity? Are we looking at them from carbon storage? They can be actually really good. We shouldn't just throw them under the bus completely.
No.
Although, obviously I don't think they were thinking too much about like preserving the ecological diversity and stuff at the time, but somehow it kind of still worked out in a lot of cases. Yeah.
No, that wasn't their intent, but that's what we ended up with. So I think you asked the question, Hengda, about where this thing was being put in. So I think you actually gave a really good description of what happened there. Went in, removed the big spruce, removed the big Doug fir. This changed the age distribution, changed the size distribution of the trees that were there, and really importantly, changed the species composition. So opened up a bunch of growing space for the subalpine fir. That subalpine fir did really well. So when we look at the actual forest composition pre-harvest, depends where you are, but there was a subalpine fir dominant or spruce dominated forest throughout the area.
Right. So, and then we go into the resistance. So that one's like light touch, right? So what do you mean by light touch? How much volume, or what is the metric you're for your harvesting? Is it based on BA or based on stem per hectare, or is it based on volume?
It's based on BA, but I'm gonna be a bit picky here in that
Yeah.
we don't just want to focus on BA. We really want to think about how we're actually shifting the species composition,
Right.
the diameter distribution, what we're leaving, what we're cutting. So doing a site prescription where you just have a target basal area without any additional information, I'm going to argue that's only doing half the job. You need to be much more specific. So yeah, we can chat about what the actual target was for the resistance treatment, this light touch as you put it. Before we go there, though, we need to think about, well, what was the thought process that actually got us to develop this? And I'm going to, if you don't mind, go on a little bit of a tangent here.
Yeah, go ahead.
This wasn't just me, Sue, Kristen, Dexter sitting around. So these are the site leads for the JPRF ASC. It wasn't just the 4 or 5 of us sitting around thinking about what these adaptive silviculture treatments should be. All the ASC sites within the network have to go through a structured workshop to develop what the actual silviculture treatments are going to be. So this is a 3-day workshop that brings in people from a whole range, a whole spectrum of backgrounds that discuss what we want from our forests, what type of climate pressures we expect our forest to undergo, and then what are the actual silviculture options that we could use in order to promote the future forest state that we want to try to maintain. So we did this back in 2019. Actually, no, I'm sorry, I got that wrong. Chris and I started talking about this in 2019. The actual workshop wasn't until 2021 when we got these people together. And the first day of the workshop is really bringing in about 40 people, having a community discussion about what we want from our forests, what type of climate pressures they're facing. And if you remember back to 2021, there was this COVID thing going around. Yeah. So we actually couldn't have the meeting in person, which was really quite disappointing. It would be nice to get everyone in the room, but like everyone else that time, we just had to sit around on our Zoom meeting, team meetings, to kind of go through what we think about this. So the first day is really talking about what the impacts of climate may be and what we want for our forest systems, getting a really large community to give some feedback. And then there's the day 2 and day 3 was breaking this down to a smaller number of people, still going across the spectrum of people from different backgrounds. So having consultants in the room, having community members in the room, having provincial researchers, federal researchers, academics in the room, as well as the ASC Network's leads. So bring this all together, and then in day 2 and 3, this was when we really sat down and fleshed out, well, what do we think would be a good silviculture treatment for resistance to actually do there. And this is where we loop back to what you're just talking about, the initial forest conditions. So if we would go into the area where the ASC site was set up, let's say 1920s, we probably would have seen a Douglas fir leading system. And Jack, you may remember, maybe you could talk about some of the stumps that we saw.
Yeah, there's some pretty big stumps out there. But before you go right into the whole biology of kind of like the species distribution and stuff, I was wondering, was it difficult to arrive at a consensus with the different groups that were there at the consultation? Like, were there people with very differing opinions, or was it kind of easy to eventually come to a consensus? Because obviously, as we know, in northern BC, there's some pretty different opinions going around about how we should manage our forests going forward.
No, it wasn't easy.
And that's kind of what I suspected.
Yeah, there was a lot of back and forth about not only what should we do, not only how we should do it, but also what we should do it. Because as you're suggesting, there really is a range of opinions in terms of how we want to manage our forests from like a pure conservation perspective of do nothing. Mm-hmm. There are some people in the room that suggested that, well, we shouldn't be thinking about doing any type of adaptive silviculture whatsoever. We should leave these systems be and just let nature take its course. To the opposite end of the spectrum of people that would be unwilling to suggest that any type of operations apart from clear cut would work. So lots of back and forth. I will say that the moderators at the workshop, they were really the superstars. So their job was to kind of bring together all these really disparate views and have us come to, if not a consensus, at least an agreement on what the treatments should actually be and look like.
Who's the moderator? Is it like a professional team that does it? Or?
Yeah, it is a professional team, but more specifically, it is the leads for the ASC network. For Linda Nagel is the professor and the one that kind of took the lead. She works with a whole group of people that are absolutely fabulous. And I think we were maybe the 8th or 9th site to actually go through this workshop procedure. So by the time they got to us, there was a well-oiled machine. They knew exactly kind of how to get these various different people in the same room, metaphorically, and have them come up with ideas that would work. So yeah, all hats off to them. They did an absolutely fabulous job. And the whole reason that the ASC network is kind of as strong as it is really because of Linda and the team that she has around her working on this. So that's how we kind of came to some type of consensus. And I'm sure you could ask people that were there for that second and third day, do we agree with everything? No, they probably don't agree with everything. They'd have their own ideas. But I'm happy with what we came up with. And I think it's a good, strong framework for going forward. So,
and I would say, like, usually in all good agreements, there's no one person who gets everything they want. Everybody has to give up a little bit of something that they potentially wanted in order to make it work, I would say.
That's trade-off. That's balancing.
I feel like sometimes people forget that, like, when they take maybe a bit too ideological of a perspective, where they don't realize that, like, if we based everything according to one value or a certain set of values, then it would be very, very hard to ever come to a consensus, because there are so many different interests and people who have, different reasons for why they want the forest to be a certain way. And yeah, that's something that we've really focused on in, I would say, our whole degree in forestry. That's just been a big focus of how do we, come to some sort of consensus agreement, and where, everybody has to give up a little bit, but nobody's like completely unhappy at the end. So, but I don't know if we've figured it out completely, but that's definitely something we're all interested in working towards, I would say.
That actually makes me extremely happy. So if there's one thing people come out of their undergraduate degree, their forestry degree with, is an understanding that trade-offs are at the heart of everything we do. And that, there is no magic bullet that's going to give you everything. There's always going to be cost benefits for different objectives. And in forestry, what we also need to keep in mind, which you two know implicitly, is that these are really long-lived systems. So you may not have a trade-off right now, but that trade-off that you should be thinking about may come 20, 30 years from now when when the systems have developed.
And that's why I find this ASC trial so interesting too, because it's almost a little microcosm of, how are we going to move forward throughout the northern interior and BC as a whole. How are we going to move forward as foresters? And I think ASC is super interesting for that, because it lays out all these different possible options. And even in the planning process, you had to go through kind of like a mini, consultation phase of talking to people in the community and experts and stuff. And so it's very, like, I think there's going to be a lot of things to glean from the ASC trial in terms of not just the the hard data on the temperatures and growth rates and all that, but also I think even just in terms of how do we come to agreements on different treatments. So that's why it's such a multifaceted trial. There's really a lot of different things that go into it.
When you say that, you're actually making me feel sad, because we've, I think, done some really good work and set the groundwork for measuring a lot of the biological responses. If I was to do this again, and given the time cost commitment, that's not going to happen. But if I was to do this again, or if I was going to make any suggestions for future sites, it would be really to focus on what you're touching on there. Do a better job of documenting and thinking about how that whole consultation process would work, and try to get some learning lessons from it. How can we actually figure out a framework for getting to some type of consensus, thinking about these trade-offs more importantly. So it would be nice if there was more social scientists working on this project, frankly.
Although I will say this podcast is kind of is doing a little part of that, I would say. Just even hearing how you were able to come to some sort of consensus and have these different treatment types. So.
No, that's a good point.
One thing I would say that, if I were designing this, I would, because I care about animals, how to respond to all these treatments, I would put on tons of cameras out there before the treatments, like have like a 5-year long-term monitoring plan, have a benchmark data collected, and then you do your treatments. And then assuming nothing happened in between, nothing changed, there's no fire, anything burned out, anything. And then you have this long-term monitoring plan of the population of species abundance and richness for each treatments, for each whatever animals you're studying.
Although it's a little trickier for like the larger animals because they're just going to walk around like even outside of John Prince Research Forest, like a wolf or whatever could, go hundreds of kilometers away potentially.
But yeah, you just need a long-term benchmark data to do the comparison. Now okay, this treatments, because you want to pinpoint to one
how much
thing.
They're utilizing the different trial areas potentially, I guess you could say.
Basically, yeah, use it for habitat, use it for preying, for or just making babies, whatever they doing. We science, we want to pinpoint to one thing. So we control everything else. We manipulate one factor and then see how the effect of that one factor has on whatever things we're studying, right? So if you don't have this large amount of data, then you cannot pinpoint because there's so many things is changing at the same time when you do the treatments. Then which one is making the animal disappear? Which one is making the birds, not coming to this site? It just gets complicated. So I don't know. I'm not even a scientist. I'm just saying a bunch of stuff that I think makes sense. I don't even make sense to you.
That's a really good point. And yeah, if we could do this again and go back 10 years before we want to do it and put out camera traps and audio recording traps, that would be great. I will say that one thing that we were actually able to leverage, given that we did set it up at John Prince, is they have this absolutely fabulous track record of having long-term data sets. Some of it overlapped with where the ask was, so we actually do have that continuity of data. So I think you've had a chat with Chris Johnson here at UNBC?
Yeah, Chris Johnson. I was talking to Dexter, talking to Shannon, trying to get on pretty much everything.
Perfect. So yeah, and they would be the ones to tell you this, but to kind of summarize, they've got some great hair and links data that kind of goes across the ASCC site. So they're keeping that up and going forward to look at what happened before the treatments and looking at what's happened afterwards. And although I don't think there was any or a large number of replicates of camera data in the ASCC site before harvest, after harvest, there's been a range of researchers actually putting out auto recorders as well as camera traps. So that is something that we do have this long-term data set being built up. But yeah, you don't know what you're going to do 10 years ago.
Yeah.
And if people are interested in seeing, I think if you go to the JPRF page on Facebook, they have some cool videos of some of the animals that they catch on their cameras there.
Yeah, we're on a tangent right now.
We have a tangent.
We have about like an hour-ish, but I still want to kind of briefly touch on those treatments, and then I want to move on to whether we should manage those forests and then for climate change. So those treatments, we touch on resistance. So
can we go back to resistance?
Yeah.
Because I don't think we actually got there. You're right. We kind of went on some tangents here.
It's a fun tangent though.
They're always fun tangents.
This is interesting. We can chat for like 10 hours.
Yeah, we could.
We should go grab a beer after this.
So let's go back to what you were asking about the state of the forest beforehand. So if we went before the diameter limit cutting or the high grading, it would have been Doug fir dominated forest. Some more spruce component would be much bigger. The subalpine fir component though would be probably considerably less. So because they did that diameter limit cut, as you guys have suggested, the subalpine fir component got much bigger, Doug fir much less. So during the workshop, when we were thinking about, what would the forest structure be that would make it more resistant, to climate change, we thought, should we actually look to the past? If we go back towards those kind of Doug fir leading systems where more adapted to drier conditions, possibly a little bit more resistant to some type of fire behavior, would that actually be what we want to promote? And that's kind of what the conclusion that we came to. That in order to go forward and make it more resistant to future climate change, we're going to look backwards to what the forest structure would have been like turn of the century or back 1930s, 1940s. So because of that, We knew that we wanted to leave the forest basically intact. That kind of set some basal area targets. So to begin with, for the resistance treatment, we knew that we wanted to have a basal area retained of around 15 meters squared per hectare. 15. And to give that any type of context, before, or the control areas, the forest structure beforehand, the basal area ranging from about 22 up to 28, some pockets where you're probably up to 30. So not really, really amazingly productive areas, but not bad.
Although for people who have a coastal context, that may not seem like super high basal area, but I would say for the interior, it seemed pretty dense to me. I mean, based on other areas of the interior I've been to, it's definitely, and even the 15 and the resistance. I mean, if you brought someone who doesn't have a lot of context to it, I think they would say, "Oh, this looks like pretty much you left almost the entire forest intact." It's I would say, visually speaking, just even to put it into layman's terms, like, obviously since the harvest was pretty recent, you can kind of tell that there's been some disturbance in there. But in terms of the structure and like the visual appearance of it and stuff, it doesn't look like that all that different from just a natural forest in the area or the primary forest to some degree.
Yeah, no, that's a really good point. From that kind of beginning conditions of, let's say, 24, 25 meters squared per hectare, taking down to 15, again, that's kind of the starting point. Now we need to ask, what trees do we want to leave? What species? What diameter distributions? And the idea was to really do a promotion of leaving the big Doug fir, the big spruce, kind of pushing it towards the community composition that would have been there historically, getting rid of a lot of the subalpine fir, not all of them, but really focusing the harvest on the subalpine fir, and leaving as many broadleaves as possible in the stand as well. Now, that's kind of the species composition. The other thing you need to think about is, well, what trees do we want to take and leave in terms of their size, age, DB8 distribution? So the thought process here was that it would be more, or that would really be a thinning from below type of operation. So the targeted trees that we're going to remove are going to be the smaller trees, leaving the larger trees, keeping the large canopy that would be there. Again, with this idea that the forest hopefully will look fairly similar to a natural forest, even though we've actually taken out a lot of volume from it, a commercial amount of good volume. So that's the overview of the resistance treatment. And as Jack's kind of implied, if you didn't know better, if you didn't really look around, there's some of those resistance stands that are frankly quite beautiful. They look a bit more open than the natural forest, whatever natural means, but they still have big trees. The animals seem to be actually treating it like a forest as well.
And like the canopy cover is quite good. Like I think very rarely are there big open areas where it's just open sky in the resistance treatment areas.
So the idea is bringing back to kind of promote this stand back to this original state before even IU logged, and then thinking that might be resistant to climate change. Is that the whole idea?
That's exactly the idea.
Okay.
So we're promoting species that may be a little bit more resistant to climate pressures in the next 20, 30 years. We're also reducing the basal area, so potentially that'll mean that there's actually less water demands, so that those retained trees will actually have more access to water, which would be good. So thinking about reduced drought stress, and leaving big healthy trees that are also going to be potentially more resistant to the stresses that they're having in the future as well.
So I guess the natural question for that is, once you open up those canopy, the sun can penetrate straight to the forest floor. Isn't that going to dry up the forest floor, and then the microbiomes in there, and the water availabilities and everything?
100% true. But that's a research question. That's why this is so much fun. We don't actually know exactly what's going to happen. And you mentioned, okay, we're creating gaps in our canopy. We're going to increase the amount of light penetration, really influence microclimates. That's true. And actually, just before we started here, I was talking to Jack about some of the data that he helped collect. So One of the things that we're doing is putting out temperature loggers, relative humidity loggers, soil moisture loggers throughout the whole site, and ask this question: when we do these different levels of retention, and I guess I'm going to have to get ahead of ourselves here.
Yeah, go ahead.
So we have our controls. Let's call that 25 meters squared basal area. The resistance target was 15. Resilience, so this is the one that's a bit heavier push. They're keeping about 10 to 12 meters squared per hectare. The transition, taking it down to about 5. And then for the clear cut, still a clear cut with retention, where after the fact, we know that there's about 2 to 3 meters squared retained in those areas. So this really wasn't the intent. We came up with each of those treatments independently, but what resulted is we basically have this gradient between a relatively high amount of retention, that 15 meters squared in the resistance, down to a very low amount of retention in the transition treatments. And now I've lost my train of thought. Why are we talking about this?
Well, I was going to say also in terms of the species composition, I guess one big thing, I assume that one of the kind of assumptions of the trial, or maybe I shouldn't say assumptions because that doesn't sound quite super scientific, but one of the maybe hypotheses of the trial would be that the more diversity of species that you have, so say you have, hypothetical 33%, 33%, like Douglas fir, subalpine fir, and spruce, that, you have, that's good. In my view, just, not speaking as an expert, but in my view, that's a much more resistant forest to major disturbances or to like whatever may come, compared to a lot of the stands that have our secondary growth now in BC that are either monoculture stands, so one species, or like 80% one species, 20% another. And I don't know exactly, even if you have the exact numbers for the splits, but like roughly speaking, it just visually, when I was there, it did seem like there was just like a pretty good mix of, and also, each hexagon varied a little bit, because I think there was 4 hexagons of each type.
100% true, yeah. So we got the 5 different treatments and then 4 replicates of each, which gives us the 20 in total, each 10 hectares, which gives us the 200 hectares in total for the experiment.
Was there any planting for resistance treatments?
Tons of planting. That's actually a key aspect for what we're doing and kind of a lot of the research that we're doing. So we want to retain some of the structure for some of the treatments. That was a big thing. But then we also want these forests to make sure that they are going to be regenerating in the way that we want them to be, so that we'll have timber that we can access again 30 years, 40 years, 50 years from now. So in each of the different silviculture treatments, there was a specific planting that was designed to go along with that. Sticking with the resistance, so the one where we're leaving a lot of basal area and kind of pushing it towards Douglas fir. There, the planting that we did was actually using local seed sources. So not actually Class A seed, but local seed sources. We're generating with that, again, with this idea that if we're going to promote the system going back to something that was similar in the past, that would be good seed sources for that. So that was frankly the kind of the boring one. Once we go on to the resilience and the transition treatment, that's where we start to think about, well, if we do want to push these systems much heavier, what type of species do we want to actually put in the ground to plant?
So it depends on what kind of climate that we're expecting in the future.
All right, pop quiz then. What type of climate are we going to have in 2060, 2080 in the central BC here? Any ideas? Any guesses?
I don't think anybody knows for sure.
Well, we know it'll be warmer. I guess that's the one thing we can say for sure, but we don't quite know too much else, I would say.
Yeah, that's the proper answer. That no one knows for sure. We've got getting better and better models, but even with those better models, there's not a consensus about what direction we're going to be going. So you're 100% correct. Warmer. That's a pretty good bet. I'd put my house on that one.
Palm tree.
Well, yeah. Is it going to be palm trees or is it going to be deserts?
If it's palm trees, we're probably in big trouble.
Banana trees and palm trees. Drum prints in 50 years.
It's a fruit plantation, yeah. But yeah, like the best models right now, they don't know if we're going to be warmer, wetter, or warmer, or drier. So this is really interesting, but it makes a challenge. What do you plant if you think it's going to be much, much warmer and drier versus warmer and wetter. So we're in the SBS right now. What would be the kind of closest BEC zone that is a little bit wetter but a bit warmer than us?
I would say ICH probably, no?
It feels like you may be cheating here a little bit, Jack. You're 100% correct. Yeah, so if we're thinking about moving from the SBS to a little bit wetter, a little bit warmer, this is going to move us towards our interior cedar hemlock type of forests. So that's exactly what we did. We thought, well, if it does become that, let's slap some cedar in the ground, let's slap some hemlock in the ground, and let's see how they do.
How are they doing right now?
Not fabulous.
The cedar has, I think, had some probably, animal, browsing, a lot of animal browsing issues probably. So it's maybe hard to say, like, if some of the issues they've been having is just due to climatic stress, or if it's more so due to animal stress. I don't know what your opinion is.
No, that's exactly right. And
there is a couple that are doing very well. Like I did, because I was walking around as I was walking to the different areas. There was a few cedar seedlings I found that were like probably close to a meter. So.
Planting cedar probably have to learn from the coast. They put like cones and stuff.
Put
fences.
Sue did buy cones, and we put cones around them. At the end of the day, again, this is an experiment. So I'm going to start off by saying that one of the luxuries that we have is that this is scientific research. And if we have a bit of a failure, that's something that is actually the point of it. You don't just want to have things work. You want to figure out what fails. That's part of the learning process.
Right.
So we put on the cones for the cedar. You're right. There's been a lot of browse. A lot of those cones have fallen down, and I'm frankly not sure if the cones were more negative.
If an animal came and knocked it over, or who knows.
But I want to pick up on what you mentioned there, Jack, in that some of them are doing really, really well. And I think that's one of the big learning lessons that we have right now, is that you've got a lot of heterogeneity on the landscape, and you really want to plant the species, particularly these species that may not be currently suited to them, in places where it makes most sense.
Certain specifically microsites, like let's say, for example, a couple of the cedars I saw that were doing very well were in a sort of sheltered little depression area at the bottom of a small hill, and obviously like quite wet also, right? Like, so one of the wetter, let's not get too like BEC nerd out on the BEC stuff, but let's just say a wetter subtype. But yeah, that's a very good point. Like, because you could say, well, cedar will never grow there, but it's like there's so many different variables that maybe there's some areas where it probably will never grow, or at least not for a very long time. But there's some maybe microsites where it could, which is something I feel like is hard to. The way the current sort of industrial forestry model works, it is very hard to specify, we're going to plant this specific, half hectare area with this specific tree, whereas, it just logistically, I feel like very tough to do nowadays, but who knows in the future.
Logistically difficult, but I'm going to argue that's something that we really need to consider about doing in the future, and that if we want to have good survival, we need to think about planting the right species in the right area. And that's not rocket science. People have been saying that forever. But to actually implement it, like you're mentioning, is something that we need to be going in that direction. And it will cost a little bit more money. But if we're saying that, well, little more time spent planting the species in appropriate areas, if you actually get a 80% survival versus 60% survival, that's going to make massive impacts in what's there in the future. So I like playing this game about what's warmer, what's wetter. So that was great. You guys nailed it in terms of what a wetter, warmer ecosystem. If I was to ask you what a drier, warmer ecosystem would be, where would you look?
IDF?
100%. Yeah. So
I'm not cheating. I didn't know. That was a guess. Anyway.
Hey, mine was a guess too. I didn't actually I didn't actually look it up before.
What do you mean you were cheating? Sorry.
But that's good. So there, promote species that may be a little bit more common there. So the kind of outliers, we put in some ponderosa pine, see how they're going to do. And you're asking how well the cedar hemlock. They frankly have been the ones that have been performing poorest so far. The amount of survival that we see from the ponderosa pine, from western larch, it's actually quite good. So really happy with that.
Because it's this dry side, right? It's DW3. It's a dry ecosystem that they're growing right now.
I'm going to look at Jack to maybe talk about the kind of specific area?
It's tough, right? Because like, yeah, you could say the overall sort of like DW3 is a drier of the SBS BEC zone, but each like we were saying earlier, each microsite, so at the top of a hill, and it is a relatively hilly area, like not huge hills, but like overall relatively hilly. And so obviously at the top of a hill, like or a little ridge, that's going to be way drier than like we were talking about earlier. At the bottom, a little bit of an indentation where the water collects. It's almost like it can even have some standing water during the wet times of the year. So a very wet SBS DW3 could be a very wet microsite, could be a lot wetter than a drier microsite in a wetter BEC zone or subzone. So I think that's one of those things where it would be nice to be able to just prescriptively say, oh yeah, it is overall just a wet or overall just a dry subtype. So we just have that in mind. It's going to be dry, but it's in reality it's a lot more complicated, and it's next to a lake too. It's next to a relatively big lake, so I'm sure that has some sort of climatic effects that I'm not enough of a climatologist to really know too much, but I'm sure it has like some temperature moderating effects and stuff like that. So yeah, it's complicated, to say the least.
That's forestry. That's why forestry is fun, though. It's never a blanket statement that can cover entire.
Well, I will say for people who know interior BC well, it is drier than, let's say, the Prince George area, and if you keep going out even a bit more east, it's definitely a lot drier than like, where Eliza Lake Research Forest is, or where, get towards the ancient forest where it is that it's already ICH there. So.
Yeah, I actually found cedar growing in SBS MK2 up in Mackenzie naturally. Naturally.
Cool,
it's
really
not,
cool.
It's not even planting. We was walking past a plantation and we saw, oh my goodness, there's a cedar tree growing in the spruce plantation. And it's in the SBS MK2. But it's right beside the lake. Yeah. So, and it's pretty south. It's not too far north, but my theory, just a bird pick up a seed and then flew over and then like poop the seed out and then boop, lands right there, and then it's right beside the lake, and then
I mean, that's what I love about forestry too, is like you're always surprised. You think you know an area really well, you think you know a certain BEC zone super well, and it doesn't matter. I was always like, because at the end of the day, it's all kind of our averages that we interpret as human beings, but nature doesn't really care that much about our averages. There's always going to be exceptions.
Yeah, back it's artificial way to scientists. We love to classify things and categorize into different things, but nature doesn't go like that. And I work with one of this Legend. I don't want to drop names, but Legend. I'm doing BEC classification. He does lots of like the PAM map, the TAM modeling, and then aerophoto interpretations up in the north. And then even when we went out with him, he cannot even give you like a clear line where the O1 type separate from the O4 type. It's nature doesn't work like that. So as soon as you start getting this artificial classification of things and natural things, you're going to run into troubles.
I like to say like nature works in gradients. It's very rarely that you have like very, very clearly defined categories like the way we picture in our head, especially when it comes to a complex system like a forest.
But we cannot live without it. So
well, they're useful. I mean, they're very useful categorizations. I'm not trying to say BEC is I mean, it has its flaws, but is overall a very useful system for sure.
Now, I'm curious, who's this BEC Legend that you're working with?
It's actually Sophia's husband, Ken. Forgot his last name.
Ken. We'll just leave it at
Ken. Great guy. I just love to talk to those people that spend their entire life doing one thing and then kind of master in one set of skills in forestry. And I was fortunate enough to work with him for 2 days and learn so much from soil texture. He carried like a sieve. What do you call it?
That's right.
Yeah, because I just eyeball coarse frag
for the
percentage.
frag, yeah.
He actually use the coarse. Is it called sieve?
Yeah,
sieve.
Yes.
And then kind of filter out the all the sands goes down, and then I think 0.2 millimeter is the coarse frag size, and then then you can really easily tell. And then he also can pre-type size series by looking at area photos.
And because for people who don't, maybe who haven't worked in forestry who are listening to this, a big thing about BEC zones, and even when it comes to this ASCC trial stuff, and another layer of complexity is that obviously the soil type plays a big role in determining, what species will grow well there, and how wet the ground will be, how even like in terms of climate change, if we're talking about drought conditions, certain soil types will be more resistant to drought than others. And so that's another thing that, you just had one of the earlier episodes of this podcast with one of the soil experts here at UNBC who was talking about, how soil often gets overlooked. But it's it's a super important part of forestry that people may not realize if they just look at a forestry from an outside perspective.
For everybody that's taking soil right now, pay attention.
Mm-hmm.
For people that have to take back in the future, pay attention.
Yeah.
I know those cores can be really dry and you just want to get all there, but these are some of the stuff. It's the fundamental skills, if you want to call skills that
the bedrock skill, if you want.
If you want to call yourself forester, you need to know. Like Ken can literally look at like a landscape, that's a lateral moraine. They can tell exactly it's going to be this kind of coarse frag. It's going to be roughly around this. The texture is going to be rough like this. You're going to see AE. You're going to see more for your humus form. You're going to see this and that. Everything he just knows. And then you go in there. Oh yeah, I'm right. He just find the zonal type, the O1 type of that whole forest, and that little elevation, that's a north facing aspect, so that's going to be 04. That's like an 08 weather. That's 02 up the slope. You're going to see Gladina. Everything's true. It's like I'm
and that's just for doing it for so many years. You just have a sixth sense for it, I guess, at that point.
Yeah, you just walking beside him, it's just like, wow, this guy is like God, this is he's just so good. Anyway, we're on a huge tangent.
I guess to bring it back, because we did go on a huge tangent. I just what I'm getting from what you were saying earlier is that essentially the resilience type and what was the even less
resistance?
The resistance, but then there's the resilience and then the
transition.
The transition. So the resilience and the transition, you're essentially to put it metaphorically, you're putting your finger on the knob a little bit more of like maybe trying to adjust into hypothetical you're being a bit more proactive, let's say, and trying to change the conditions into what we might expect to see, or a couple different conditions we might expect to see is what I took from what you were saying.
That's 100% correct, Jack. You can think of it as being how far you turn the knob. For the resistance, it's a low term. For the transition, it's really cranking it up to what we're going to get here in the future. And again, this goes back to what we were talking about before, is the time scale and the trade-offs. So it may be quite a bit warmer, quite a bit wetter come 2080, but we're planting the trees, or we did plant the trees in 2023. So you then have this kind of species being separated from what the future conditions are going to be, and that's something we need to think about. We're going to have more mortality when we plant them, but they actually may be better pre-adaptive in the long term. So one of the fun things about forestry is this long time scale. One of the big challenges is these long time scales. We don't know exactly what the future is going to be, and we may have to accept that there's going to be this disconnect between what we're doing right now and what would be really beneficial in the future. And that's kind of what the transition treatment is doing much more. We know that the area is going to change, and we're going to actively, adaptively help it move towards those future conditions.
Yeah, I'm just looking at the time right now. Probably going to skip resilient and transition. But I want to talk about the clear cut. Okay. Because clear cut is what we've been doing in this business as usual. These people have really strong negative opinion on it. So is the John Prince, the treatment that you guys did, is that the same clear cut compared to... Well, first of all, many people don't even know clear cut is not purely clear cut. It's called clear cut.
Nowadays, it's not.
Clear cut with reserve. Yeah. By law, you have to reserve 3.5% for each block, and each cutting permit happens 7%. So it's not purely clear cut. But what's the treatment for John Prince? So what kind of clear cut is the John Prince clear cut?
So and I think calling it a John Prince clear cut is good in that
clear cut.
Well, no, we can talk about the John Prince, because
Okay.
John Prince does a lot of forest management outside of the ASC experimental zone, where they're still using this type of mindset. And the mindset for doing clear cut, nothing wrong with clear cut, they're using it on their land base, but it is maybe a little bit different than what people would normally think of if they just walked to a random block and said this is a clear cut. It is a little bit higher retention, and specifically, and here I am going to talk about the ASC treatment itself. The harvesters were told not only leave some retention, but specifically don't knock down any of the broadleaf component, the deciduous component, if you don't have to, which seems a little strange, but we often just knock stuff down, kind of thinking the mindset maybe opening up the growing space for the planting, allow the forest to come back nicer in the future. I'm not sure if that actually works.
Not to mention that we also spray and brush sometimes to get rid of broadleaf competitors. So
The idea is to have total control of the cut block, right? You want to plant the stuff that you don't want any competitions. You want the full control of this farmland, tree farms.
That's a great way to put it. And yeah, you're 100% correct. The more that we can control it, the more that we can model it, and we thought we'd have a better idea about what that forest stand is going to be in the future. I think that's something that we actually have to reconsider. Let's give up a little bit of control. Let's keep a little bit more heterogeneity on our forest blocks, and that gives us more flexibility in the future. So again, we can go off on tangents here, but
because that could be its whole own podcast,
This is fun part of forestry. Anyway, sorry, keep going.
To go back to your question about the clear cuts there. So a lot of the blocks that were clear cuts had a good deciduous component, and there was 2 blocks in particular that I remember immediately after harvest looking at them and saying, wow, I'm looking at aspen parkland. They probably much exceeded the target 2 meters squared per basal area that we were said, but it was all aspen. So all the conifers were removed, but you still, in some pockets, up to 8-10 meters squared per hectare of aspen being retained there. Those have changed a little bit in the past couple of years, a little bit of blowdown, a little bit of sun scalding, because that's another question. Well, when we leave these things, they're being shocked by being put in this new environment. I used to have all these happy neighbors around me. Now I'm standing here naked, being exposed to the sun. That can have negative impacts on them as well. But I guess my point being is that, the JPRF ASC clear cuts are doing what a clear cut is, removing all the merchantable species, really getting it ready for a plant as being the way that we're doing the regeneration. But they were keeping a bit more basal area than I guess we'd probably normally think of, even with a clear cut with reserve type of system that we use in the central interior here.
What do you do for advanced regen? Do you keep them or do you knock them down? Or you don't care? Do you just let the operator do their thing and then whatever's left is left?
No. So the operators have to be working efficiently. They have their targets they're trying to hit, but they were explicitly mentioned that no, don't knock down the advanced regeneration if it's there. If you don't have to mangle it, leave it standing, because we want to use that. What that means is going to vary across the treatments. So for the clear cut, there frankly wasn't a lot of really meaningful advanced regen left on the blocks. But for the resistance, resilience, even the transition, for when there was a tree that was being maintained, and let's talk about the transition. So the target was, they were told, keep around 5 meters squared. You're going to have to choose what trees those are. Could be a big cottonwood that we want to keep on the landscape for wildlife reasons, or a really nice big Doug fir that we want to keep there. Associated with that, if there's neighbor trees that you don't have to knock down or don't really have any merchantable value, keep them on the block. So in those cases, there were these neighbor trees that were maintained for a whole range of reasons. If by keeping those neighbor trees, you're going to modify the microsite conditions a little bit more, you're going to potentially make the area less susceptible to wind throw, those type of issues. So that definitely was done for a lot of the advanced regeneration, primarily in the resistance, resilience, and transition treatments, not so much for the clear cut.
Perfect. Okay.
And I guess one last thing in terms of how it may differ a little bit from a more typical or traditional clear cut that we normally see. I believe that they used more the European style, like harvester forwarders, right? So the slightly smaller machines,
Smaller,
stump
nimbler.
side processing mostly, I think. Right?
Everything was stump side
Yeah,
processing.
okay,
Yeah.
so-
And that's a really good point in that when you look at it, it's a clear cut, but the way that it was processed and the amount of coarse woody debris that was left on the block, that distribution of the coarse woody debris was considerably different. But yeah, you describe it as kind of a European system, and that's a good way of looking at it. Smaller machines that could go in, be a lot more nimble in terms of not damaging the leaf trees and really being selective, having the operators being very selective about what they want to take. So that is a difference from classic clear cuts that we've probably been using for the past 20 years.
And like in the transition and the other trial types, obviously you had to use that system because otherwise you just wouldn't be able to thin it properly. But even in the clear cut, yeah, like you were saying, it has its benefits. I think the reason they were able to leave so much of a deciduous component and just visually speaking, it looks less disturbed, the soil and stuff. We went, I guess it was around 2 years after they harvested, or roughly, right? So
That's right.
it had a little bit of time to sort of for some, new understory species and stuff to grow up. But compared to other traditional cut blocks I've been to, it definitely, I would say, looked less, disturbed overall in terms of, you had some skid trails, obviously, or I guess not skid trails, but access trails, but it wasn't like you also didn't have big piles everywhere, right? Because with the stump side processing, you didn't have these big sort of brush piles that you typically see in a traditional clear cut.
Yeah, no, that's a big difference, and you're right, Jack. And that has other carry-on implications. So if we're walking into those blocks immediately after harvest, you would have seen a lot more coarse woody debris all throughout. There were trails where the machines were operating. They put down brush mats there, so you got a buildup of kind of bigger material. But even throughout the whole matrix, the areas where the machine wasn't going, but the boom was reaching in to remove the material, there was still a lot of coarse woody debris in those areas, which leads into those trade-offs that we were talking about before. This may be really good for retaining nice forest structure, but by using that type of forest system, there's a big input of coarse woody debris. And if you're looking at it through the lens of fire risk, you could say, whoa, this is terrible. We've just made all these fine woody debris, coarse woody debris that are on the block, which again is something that we're looking at. So asking the question, what's happening to this coarse woody debris? What's happening to this fine woody debris over time? It looked really ugly, messy the first year after, but then now we walk into it 2-3 years later. You can tell that there's a lot of coarse woody debris on the ground, but it's maybe not nearly as scary as it looked that immediate summer after the winter harvest took place.
One, because there's a lot of shrubs and brush that kind of has grown up in that time, and so I'm sure that I'm not a fire expert, but it's not just dry wood sitting around on the block. It's being sort of getting converted slowly into soil and stuff. You can tell.
I know my friend Alex, your undergrad thesis student, he's working on that. I'm really looking for her findings, because that's one of the biggest criticism for any type of stump side processing. That doesn't have to be forwarder. You can also do stump side processing with the processor. Mm-hmm. It's the same thing. But any type of mechanism that process the trees at the stump, fine fuel is the biggest criticism, because you're leaving all this stuff in the forest instead of burning them or hauling them out. These are fuel that you leave on site. So I want to know if it's actually a fair criticism and what's your finding. And also, you open it up, is it actually helping? Is because within the forest, the whole idea is, within the forest, we don't have those branches touching each other's. But the criticism is now you open it up, the gap penetrates, the sunlight goes into your soil, going to dry your soils up, and then it's going to dry your fuels up. It's going to burn faster. So there's a very divided opinions. That's actually a good segue into this divided opinions about whether we should even consider to manage our forests for climate change. If I can, I'm just going to put on a environmentalist, or what's the better word, conservation hat or something, that I am concerned about if this trial proceeds and then the finding comes out, people's going to use this as an excuse to keep logging the primary forest, the natural forest, the stuff that hasn't been touched by industry before. I think, as an environmentalist, natural forest is most resilient, most resistant to climate change. They are the complex, self-sustained ecosystem that survive thousands of years, hundreds of years, or any kind of disturbance. Or I will argue these disturbance are a key component of the ecosystem to create death. Yes, to create fire, to create insects, but these are the key component of the ecosystem. That's how they regenerate. That's how the succession starts. So I just want to pick your brain of whether we should even consider to manage our forests for climate change. There are lots of uncertain things. We don't even fully understand what climate change is going to be. We don't even understand how our forest, silviculture treatment is going to have a long-term impact for the timber value, for the wildlife, for the biodiversity, for all kinds of values. We simply do not fully understand. Why should we go on and manage our forests for climate change?
Yeah, so I'm sure you're making this a bit more of a pointed question there.
Yeah, lots of edges here. Yeah, sorry. Yeah, go ahead.
But I think the entry point that I'd use for that type of discussion is that what we're talking about is anthropogenic modifications to our environment.
Yeah.
And unless you are going to come at it from the perspective of being a climate denier, we are already drastically modifying our system. So we talk about natural systems. Often we kind of separate a really heavily impacted human impacted system from a system that's not that directly impacted. I'd argue that our forest systems are having big impacts through climate change directly, but also through suppression of fire that we've done over the past century. So these are not systems that we've got our fingers in them already.
Right.
And that's not, and don't want to say that I think we should be harvesting everywhere. I think there's a really big benefit of keeping some natural areas or areas where the amount of human impact is going to be really minor. But we want to think about, well, what are the processes in those natural areas that are potentially going to make them more resilient to climate change, as you're kind of arguing here? You mentioned complexity. That's great. Complexity generally is a really nice way of giving a system more options, more ability to actually change, adapt to future conditions. There's many cases where we can actually systematically add complexity to a mature stand in ways that may actually make it more beneficial by moving it towards having some of those characteristics that we usually think of as being really good old growth characteristics. So a gappy structure, a lot of microclimates that are going to be interacting with each other, lots of niches for lots of biodiversity. So I want to be kind of clear here, but also vague. Vague in that, or not want to be clear that keeping some natural forest can be really good. We should be thoughtful about where we want to do that and really what we're trying to promote. But we also shouldn't paint all forest intervention as being bad, in my opinion. That as long as we're thoughtful about what we're doing, that it can actually be really good for promoting the type of forest structures that we think or that we know are going to be good for keeping forest ecosystems vibrant going forward, particularly under things like climate change.
Mm-hmm. I would like to add to that in the sense that I think some of these people who take a very hardline view of against any kind of active management, I think part of it is because, they have a lot of mistrust for the forestry industry. Some of it, which is probably valid, and, that bad practices that happened in the past that led the public to lose some trust with forestry as an industry. But I think one of the big things is people view this sort of idea that, if people, they're going to say, we're going to manage it in this kind of new, more way that sort of emphasizes this resilience or this resistance and kind of takes these things much more into consideration. But they just don't trust the forest industry, so they think, this is all rhetoric, but in reality, it's just an excuse to go in and, maybe they'll leave a few more trees than they used to, but it's still going to be like this, pretty much a clear cut or like just very, very heavy impact. And I understand that sort of people who hold that viewpoint, and there's probably a kernel of truth to it. But at the same time, I feel like we should be able to have these discussions in good faith, right? If a forester, someone like you or I, who are going to be foresters in the future, says, no, we actually don't want to have we do want to see changes in how forestry is done, and we do want to see practices shifting in the future. I think it makes it very hard for us if people are just going to say, no, we don't trust you, so you shouldn't do anything. Because at that point, then it's like, okay, well, why even try to do this more sustainable or this more flexible forest management if people are just going to assume the worst, right? So that's what I would say to anyone who's listening to this podcast who has some mistrust for the forestry industry. I would say that I'm sure there's probably reasons why you have that mistrust, but that the people I know, the majority of the people I know, students who are coming up in forestry, in our generation of foresters, really do take, resilience and climate change very seriously. And that I don't think it's all just an excuse to go in and get more volume. I think that there is, people who really do want to see how we can continue to manage the forest in a way that can provide some economic benefit, but also takes a lot of other things into consideration. So I think that's a big thing. And also one other thing that I would just like to say is that, yes, it's true that these ecosystems have survived for thousands of years in certain various forms, but I think you know more about this than I do, but I think that climate change, the speed at which the climate is changing, is something that is essentially, and the projections that we have is essentially unprecedented in terms of how fast the climate is changing. So while there has been large fluctuations in the past, I think it was I don't know in how long there's pretty much never been this fast of a climatic shift. And so that's something else that I would like conservationists to maybe take into consideration, is that we don't know if just leaving the forest to be natural will enable it to do well, because it may be just the speed of which, and especially, even for the ASCC trial, I think probably the John Prince is such an important portion to it, because the further north you go, right, in latitude, the more climate change has increasingly severe effects. Like the climate is changing faster the further north you are on the globe, or the further south as well. But like the extreme latitudes is where it's changing fastest. So to just say, yeah, it's worked for thousands of years, it's going to work going forward, I don't think that is a very sound reasoning that we can just assume that. So those are just two things, because I've heard all these arguments a lot and I understand where they're coming from, but at the same time, I think that if we have some good faith in these kind of discussions, I think it can be very beneficial, and there is ways going forward that we can do things, and we can take a lot of different values into consideration, and it's not just gonna all be an excuse to go in and clear cut huge areas. So that's what I'll say. But
if I can build on that, Jack, I think there's two things there that I'd like to kind of expound upon. And the first one is, we don't really know if leaving the system without any human impact is going to be beneficial. But again, that's something that we're actually testing to draw it back to the ASCC trials. That's what the control is doing. We're going to monitor forest health. We're going to monitor forest growth within those areas where we've done absolutely nothing, and ask the question, does it seem to be more resilient to climate change over the next 20 years, or does it not? So we need to be careful about saying that we know exactly what's going to go on. No, I'd agree we don't. We still have to do a little bit of testing. And the second thing, which I think is even more important, loops back to the workshops that we use to develop the actual ASCC treatments here. I'm going to strongly argue that you want to have all those voices in the room, or we should have all those voices in the room going forward, thinking about what the forest sector looks like in BC. So I want to have those conservationists. I want to have the people that are coming at more from the timber perspective. We need to come together, talk, think about what that would actually mean. Again, I'm not advocating for doing forestry everywhere. I'm a strong believer that there should be some areas where there's absolutely no entries whatsoever. And there could be a range of different reasons how we identify those areas, where they are in a landscape context. So that's very valuable. And we want to make sure that everyone's voice is really being heard, because these are big decisions that have really long-term consequences for the forestry sector, as well as just our whole biodiversity, our whole landscape in BC for the next 100 years.
I think all these negative, well, I shouldn't say all, lots of the negative opinion about forestry is, you can say whatever the fancy stuff you said. Foresters can make themselves sound like, sustainable, whatever they want. I take a plane to Vancouver. I see the checkerboards on the landscape. I see club blocks after club blocks after club blocks. Like, how is that sustainable? How is, you can bring up, whatever the plan you have, forest stewardship plan, the forest landscape plan. You can have the best plan or whatever. I care about the result. I care about what I'm seeing. As a general public, I probably don't even know all the stand structures, BAs, and volume that you guys talking about. I care about when I go out, when I drive out there, and when I take a plane, I see these cut blocks. So that's something which is also one of the recommendations from the Old Growth Strategic Review, which is diversified our silvicultural prescription. We have so many tools. Clear cut with reserve is one of them. And then we have shelter woods, different variations of shelter woods. We have selection harvest, different variations of selective harvest. I was developing... You've got
individual tree selection.
This is one of the projects I'm working on for you, actually. I was just reading the how Wisconsin back in 1926, and there were lots of high grading. There were lots of, they call it exploitative logging. And the public said, well, we shouldn't do this. We need to come up with an alternative way, which is really similar to BC right now. So that's when they developed the single tree selection. The forest is different. It's a hardwood mixed with forest. We have this coniferous forest that I will argue, even for pine forest, I think is important to regenerate them in an even age fashion, because that's what they naturally regenerate. We talk about lodgepole pine, jack pine, stuff like that, because they have, serotinous cone, they're shade intolerant, they need light. But for some of the spruce, or you go up elevation, the ESSF in the subalpine fir area, is clear cut a better way to do this, or is there a better way, other way we can do this?
Well, that's why, to my mind, it's frustrating, because sometimes I hear the conservation argument and I have sympathy for them, but it seems like a one-size-fits-all approach, which is exactly what people have criticized industry for a long time, and I think rightfully so. But I think it's switching to a different type of one-size-fits-all, where we leave all the forest untouched, or even all the primary forests. Like, I think having a one-size-fits-all rule that says we can never go and touch any more primary forest, I think is just not a very natural way of thinking, because there may be some areas where it just does make sense to go in there, and whether it's salvage logging and done in a responsible way, or like high fire risk areas, like there are just certain exceptions should be made, I think, in certain scenarios on a case-by-case basis. But even saying that we're not going to touch the primary forest anymore, supposedly, but there's so much secondary forest in BC, and that forest needs to be managed. I think people who say that we could just let the secondary forest as it is now keep going for the next 100 years, I think that's a recipe for disaster. I think the secondary forest as it is now needs to be managed more. I think a lot of the stuff, even with the ASCC trial, is a very good sort of model that you could use for areas where it is very monoculture-ish or low diversity. We could go in and thin it out. We could do different types of selection harvesting and plant some and have a greater variety. So, yeah, it's look, I think the checkerboard clear cut model has kind of, I think it's consensus with most foresters nowadays, especially the younger ones coming up, that model is kind of seen its day. It's I don't think it's going to, in 50 years, we're going to be doing clear cutting the way we do now. But there's there's not a one-size-fits-all approach. We can't just leave it all.
Then I would put on my forest economist's hat. Clear cut makes some money. Well, clear cut, I'm losing money even doing clear cuts. I can't even, the mill's shutting down. Obviously, this model is not working. How do you want me to do selective logging to still feed my family? We are taking less volume. We're using more expensive machine. Yeah, but I'm burning less fuel, but I'm taking less volume out of the forest. I'm making less money from this piece of land, and I'm losing money even doing clear cuts. How can I switch to a selective logging?
Yeah, so now we're going into the realm of kind of really more fundamental changes that may have to happen in the forest sector. But I think the way that question's often presented needs to be revisited. You're right, the mills are closing down. Were those mills designed to actually be reflecting the amount of annual allowable cut that we'd historically have, or have they been inflated through things like the mountain pine beetle epidemic? So, yeah, the economic side is extremely difficult, and you don't want to walk away from the point that this is going to cost more money. That's something that needs to be built into it, and we need to think about, how are we going to rework our forestry sector so that there still is an economically viable way of making money from the forest, but keep in mind that we're not just growing our forest for timber value. If you do want to do that, you could make the argument that, clear cut everything, plant everything, goes back to what you're talking about before. We want to have a really highly managed system where we know the results that we're going to get. Those type of forests may not be great for biodiversity. They may not be good for wildfire resistance. So we need to think about our forests in a more holistic way, the multiple values that we're actually managing for. In this day and age, that isn't surprising. We've been doing that for the past decade.
Well, and I would say, if you completely lose the public's trust by continuing to just business as usual, there may come a point where, harvesting of any kind gets banned just because public opinion then goes so against the idea of continuing to harvest. So I think it is difficult, obviously. There's no, again, what we were talking about earlier about even setting up the ASCC trial, there's always trade-offs. But at the same time, I think people who just want to keep going on business as usual 100%, that probably is, I don't think forestry has the social license in BC to really keep doing that for much longer. So that's what I would say to the complete other side of the argument of the people who are just focused on the economic values, is that I think there needs to be some sort of middle ground. Where that middle ground is going to exactly be, I don't know. That's going to be something that the public and the industry and the experts are all going to have to come together and we're all going to have to figure out. But I don't think it's going to be on one extreme or the other. I just don't think that can really work.
Can we jump from here back to something we were talking about before, and that's not really knowing what the future is and kind of how to best manage for that uncertainty? And it's actually in the title of the ASCC trials, the Adaptive Silviculture for Climate Change. I think we should keep that adaptation and adaptations options really at the front of our mind as we are foresters going forward, thinking about how the whole sector is going to change in the future. So if we just have a system where you clear cut, plant a pine plantation, and plan to come back year 70, year 65, do another clear-cut harvest, that type of model provides very little options for actually doing adaptive silviculture. And this is something that we've been talking about for all different types of management systems, fishery systems, adaptive management for over 40 years at this stage. If we go back historically to how forestry has been done in Central Europe or even on the East Coast or here in the past, you'd have multiple entries and the forester would be thinking about, okay, let's look at my forest right now. Let's think about what I can take. It could be high grading, just taking out the big Dougford, big spruce. But coming in every decade and reassessing, now what can I do? How have conditions changed? Are my objectives changing? So really having this update on what we should be managing for at any one point in time and what is the appropriate silviculture system to do that. So where I'm going with that is when we're thinking about adaptive silviculture for climate change or just adapting our whole forestry sector, we shouldn't look at it as doing everything everywhere, like you're kind of suggesting, either clear cuts everywhere or other type of management systems, actually building in the flexibility so that we can respond to changing market conditions, changing environmental conditions in a meaningful time frame. That's not a 50, 60-year-old window, but actually doing this reassessment every 10 years, every 20 years, so that we have a lot more control, a lot more ability to actually influence where the system goes.
This is a really interesting talk, and the reason I asked those questions and kind of putting myself in a spot and then kind of challenge you, and also challenging myself, to think from different perspectives. And I think whether we like it or not, this is something we have to deal with, is the differences in perspectives, especially in forest management. There's a crown land. Everybody have a say on this, and how can we have a meaningful, constructive conversation without getting too emotional and start getting this blaming game.
Do you know one of the best ways of doing that?
Yeah.
Is by taking a field tour and walking with people through different treatments, which, again, I'm going to be promoting the ASC trial here, but that's something that Dexter and the John Prince has actually done an absolutely fabulous job getting different groups, be it licensees, be it communities, to actually just go for a walk with them in the forest, say, well, what do you see here? Let's talk about the economics a little bit in terms of the costs, whether or not we actually made money from this, but also let's just talk about, well, what are we doing? Having that conversation in the field can be so beneficial. So that's the other kind of value of having these large-scale operational trial sites. You can actually go and walk with people through those forests and have them do exactly what you're suggesting there, Hengda. Have this kind of thoughtful back and forth about what our forestry sector should be doing, what we can actually do different, what the cost benefits are. Because it's not always rosy. We're not going to say do a selection system everywhere, group selection. No, there's going to be places on the environment where that likely is going to be a better system. Other places where it's completely wrong, where a clear cut would be good, or doing pure conservation and making sure there's no human impact or as little human impact as possible.
Yeah. I just want to give two places a shout out. One's Freya Log and Liam. Well, he did all the cutting in jump prints for the ASC trial. He also thinned the Perdurny bike trail, whatever that thing called. Mm-hmm. I actually walked the trail with him, and then we met a trapper. You can tell he has very strong opinion about forestry, but we kind of walk the treatment area with him. He's so impressive. Mm-hmm. And this coming from the trapper. Just think about trapper and then their stereotypic attitude towards forestry, right? So I think that's really important. And then another place is Eliza Lake. They just did a cut block in 3B using single tree selection. I just recently filmed a little thing in there. It's probably going to be released pretty soon. Basically, if I don't tell you, you never know it's a cut block. It's covered in snow right now. They took off 50% of the trees, 50%, half of it, and you go there and it look just like a forest. There are different canopy layers, horizontal, vertical structure complexity there, and species compositions diverse, and without getting too technical, just a visual presentation, it just looks like a forest. So there are lots to talk about, but we're gonna get kicked from here. So is there anything else you want to talk about, Che? That
I guess one thing, like, I don't know how much do we have, like 10 minutes or how much do we have?
We have like six minutes.
Well, if you could just like really quick, maybe just I know like in the scale of how long the ASC trial is going to be, we're still at very early stages, but if there's just any preliminary results of maybe some data you've seen that indicates a certain trend that you've found to be sort of interesting, just a short summary of that.
Sure. And I'm going to loop back to the data that you're actually familiar with. So one of the big questions we're asking is, by keeping this overstory structure, how are we actually modifying the microclimates that are available? And that's going to be important for a whole range of reasons. We touched on fire. So you've got this coarse wood debris, fine wood debris loading, but if it's really moist, the fuel moisture content is really high, that's not going to be a big risk. So there's the fuel side. We're creating different microclimates for our regeneration. So by keeping a little bit more overstory, are we making forest conditions, microsite conditions that are less extreme so that they're actually going to have less mortality of our seedlings, promoted good that way? I'm sorry, what was your question, Jack?
Yeah, just like if there's any trends you've seen in the data you've collected so far that maybe has like some sort of interesting indications of what might be the differences between the trial types.
Right, yeah, okay. And the reason I jumped on the microsite conditions is that that's something that we're starting to look at here, and there's some really nice trends where if we think of the clear cut, you're removing a lot of the material, you're going to get much bigger maximum temperatures, bigger minimum temperatures as well. So a lot higher frost events, a lot colder temperatures during the summer, but also a lot warmer. So thinking about future drought resistance, keeping overstory is one of the big impacts there. And so far, if we just look at maximum daily temperatures, minimum daily temperatures, you do see kind of a consistent change with the amount of overstory retention that was being done there. So big extremes in the clear cut, least fluctuations in the resilience.
And I think another big thing would be the big, like slightly more resistant to extreme events like the heat dome we had a few years ago, because those will be more common going forward. So it's not necessarily even like a long-term drought, but like extreme events like that, right? That's pretty important to consider as well. Yeah,
and we have people looking at the coarse woody debris, the fuel loading they're talking about, getting some really interesting results there. Not as big a differences as we'd expect, and the differences are really decreasing through time. So talked about this before. Immediately after the harvest, you went in there and said, oh, this is a mess. Look at all these fuels. Those fuels have gone away, particularly the fines, because of those high moisture conditions, really good decomposition conditions that are being created there much quicker than I probably would have expected. And the risk at this stage from fire, I don't think is much higher in those areas compared to the other ones. So keep your eye out for the results that we'll be putting out for that. The seedlings so far, we're only in 2 years post planting. So that's just a preliminary, but we're still seeing nice results with regard to differences in mortality across the treatment, similar to the extremes that we're seeing in those areas where there's less physical extremes. Our survival seems to be a little bit better, particularly for those species and for those provenances that were pushed outside of their comfort zone in terms of where they're being planted. Now, there's a bunch of other work being done in the trials for wildlife impacts. That's some of the kind of first results. So Ken Otter and his research group has been looking at bird communities there, and their initial findings seem to be that in those resilience, the kind of higher retention areas, the birds, some birds, not all of them, but some birds absolutely love it. So you were mentioning before that you walk through those forests, you can't really tell that there's been a big harvest operation done, and the same thing seems to be, that's what the animals are responding to as well. So keeping this higher retention can be good for wildlife. We always want to think about the trade-offs with that, but it's part of this kind of whole story that we need to consider when we're actually thinking about the silviculture options that are going to be beneficial and adaptive to climate change.
And even some things that people may not consider right off the bat is there's even some scenarios where taking some volume out is actually beneficial to certain animals. Let's say moose, for example, is gonna they'll probably have more browsable kind of shrubs that grow because of a little bit more sunlight reaching the understory, but also just way easier to move through. Because I'll tell you, the control ones where there's no treatment at all, they're hard to walk through. They're quite dense. So if they're hard for us to walk through, they're hard for a moose to walk through, or a bear or whatever. So that's something that so it's not always 100% the case that not touching it at all is always 100% the case that it's better for every animal. Like it's complicated, like I said earlier. But yeah, that's very interesting though. Just like some things are what you would expect, some things are like maybe not so much. Like you said, the coarse woody debris going a lot faster, getting lower a lot more quickly than maybe you expected. That's very interesting. Yep.
Yeah, so we've got some really nice results so far. As you mentioned, we're still kind of at the early days, but the results are starting to roll out. I may actually use this platform to give a little bit of a plug. Like, this is a long-term experiment, and currently we're actually looking to attract master's students, PhD students. So if any of your listener audience is really keen of doing a fabulous graduate degree at the UNBC, have them get in touch with me. I've got a range of funded master's programs available, as well as PhD positions. So we're going to be doing this for the next while. It'd be lovely to come back 6 years from now when you've got your television program and your national syndication, and we could sit down and have another chat, Hengda.
Yeah, my next Netflix show.
Exactly.
I'll come back and promote that. We kind of have to go. Obviously, this is a super interesting talk.
This is a great talk. Yeah.
And I feel like we can keep going for at least 2 hours. But we're just going to end right here. So I just want to thank Che and Jack for coming and kind of talk to us, or us, I guess.
Well, thanks for having us.
Yeah, thanks, Hengda.
Yeah, no problem. And I want to thank the Seafer radio station for providing this place for us to record. Otherwise, we can never do this. So this wraps up this episode. I forgot which episode of the podcast. We thank you for tuning in and listening to us chit chat about nature, BC forestry, and life at UNBC. So UNBC Forestry Club Podcast is a student-led podcast sponsored by absolutely nobody but a bunch of students who are passionate about forestry, the outdoors, and adventures. So new episode drop weekly, so stay tuned for more insightful conversation and inspiring stories. Until next time, let's continue to grow together, rooted in our love for the forest. Have a great week, and we'll see you in the next one. Thanks, Jake. Thanks, Jack. Thank you.